So let's say you are walking around with me and I point to some rock that's right there or a stone and I say, well, kids, this rock was not here before. And you say, what are you talking about? How do you know that? Well, here we are talking about that. Wandering stones in North America, Russia, and Northern Europe. You can find wandering stones all over the place. They are more commonly known as glacial erratics. These are big boulders that don't actually belong there where they are found. Some of them are bigger than a car and 20 times as heavy. The big rock erratic near Okotoks, Alberta, Canada is the size of a two-story house. There is no mountain nearby that this stone could have come from, and that's rather strange. It's not like it was sitting on a mountain and then just somehow came rolling down, right? So this happens a lot. So it's not normal to come across boulders like these in the mountainous regions. They are just pieces of rocks that have crumbled. So, sorry, did I say it's not normal? I read it wrong. It's normal to come across boulders like these in mountainous regions. They are just pieces of rock that have crumbled away from the mountains like this. When rivers are flowing quickly enough, the stones can hitch a quick ride and end up somewhere downstream. So if you're on a slope and the water comes and lubricates the bottom, then the rock might slide down and the gravity then does the work and takes it far away. Okay, so a little ride can end up taking it somewhere else where it doesn't belong. But when the waters are calmer, it can only carry gravel and sand, so smaller rocks get carried with it. Yet even in countries with no rocks or mountains whatsoever, you can still find plenty of large stones that came from mountains and far away from the mountains. The biggest ones are sometimes nicely presented on town squares with helpful information on a board next to them saying, kids, this rock came from somewhere else. So you can see there's a curious person with his daughter driving around, and there is a big rock with a little devil peeping out. There are lots of stories about these mysterious wandering stones. People say that the devil carried them like this one, or that they grew out of the ground all by themselves, or that babies came from underneath them, or that fighting trolls threw them at one another and giants stacked them up to make megalithic monuments like the big pyramids and so on. This is all nonsense, of course, if you know the science, as is the story of the Great Flood, which many religious people use to explain the presence of these stones. We need more science, but lots of scientists in those days wanted to believe the Bible, so they figured that icebergs had transported the boulders across the water. When the ice melted, the boulders were left behind because they are too big to be carried by the water. They didn't have the whole story down, but they were heading in the right direction. Okay. In 1837, though, the Swiss geologist Louis Agassiz came up with the idea that stones had been caught in big areas of glacial ice. These glaciers had carried the stones along for thousands of years and simply left them behind somewhere when they melted and the water went away into the oceans, often in a place where they would never typically be found, in fact, which is what is always confusing. This must have happened at a time when Europe was covered with big ice caps, which is of course an ice age. There was enough proof for this theory. In mountains you can clearly see marks that stones scratched as they came past the glaciers. They're called glacial striations on rocks. You don't get scratch marks as if a cat just scratched your arm or so. The same kind of scratch can often be seen on the stones too. You can also see traces in the landscape that were formed out of the material the glaciers had taken with. So as glaciers grow, the water seeps in, freezes, breaks everything, and then keeps pushing in front of it whatever it can push ahead of it. Right? So you can see the traces in the landscape that were formed out of the material the glaciers had taken with them for centuries. Some examples include Cape Cod in the United States and the Oak Ridges Oak Ridges Moraine in Ontario, Canada. They show exactly how far the ice came. As you can see, I have an accent. I'm not a native English speaker, but I hope what I'm saying is always clear. There were also earlier scientists who had talked about ice caps. James Hutton, for example, the man who was interested in the layers of the earth, but in his time people hardly paid any attention to such strange ideas. Agassiz, or Agassiz as it's pronounced in Sweden, also had difficulty convincing his contemporaries. He was telling his colleagues, this is what is happening, and they said, you are crazy. However, he is now known as the discoverer of the ice ages, and so also a little bit as the discoverer of climatic change. If he said ice ages came and went, then he was talking about climate change, of course. However, there are some other people who might deserve that title too. So here's Louis Agassiz sitting on top of a nice big boulder with somebody here having carved I love hard rock, and Louis was here. Right, so lived from 1807 to 1873 and was a geologist and was in love with playing with rocks and figuring out where they have been wandering around over their lifetimes. Okay, now we move forward and think about who discovered the greenhouse gas. Right? Maybe we should do that in a separate podcast, even though this podcast is only about 7 minutes, but you get the idea. Whether the glacier is flowing down the mountain or it is spreading on a flat land, as snow falls and freezes, it begins to go into the pores of the rocks. And like if you're from a cold country like Minnesota, let's say cold state like Minnesota, after the winter the roads are all broken up and lots of potholes all over the place because the water got in and it froze. When the water freezes, what happens to it? It expands, right? So sea ice floats because the water, when it freezes, the molecules get arranged in a way that the volume increases, and you know that the density is mass divided by volume. For the same mass, if the volume increases, then the density decreases. You can write the little equation rho equal to m mass divided by v, and increase v and you will see rho should decrease, which means sea ice floats and glaciers float as well. So when it expands, it cracks open the rocks and the land and covers the land with ice and pushes everything ahead of it as it grows, and the rocks are sliding by or the glacier is sliding by. It's freezing and scratching the rocks, leaving behind the glacial striations. Google it and see, you find some nice images. Or next time you're walking around, always pay attention to the rocks and you see scratch marks. You say, Dad, Mom, what is this? Is this a glacial striation? Okay, so the stuff that gets moved by the glacier is called moraine. Ground up rock or rocks just carried by ice and snow on mountain slopes where glaciers were there before. You can find on the side little tiny rocks all ground up, and sometimes they are called thilites and sometimes called terminal moraine because it kept going till the ice stopped growing, and then all that deposit stayed there and the ice went back. There is one big island that got formed by such a terminal moraine. Maybe some of you already know it. Maybe you know where it is. It is Long Island, New York State, northeast US. During the last ice age, when the moraines kept getting pushed and left as a terminal moraine, it was such a big pile that as the ice receded and the sea level came up, it just became an island, and we live on it now. It's called the Long Island. Okay, so these are the nice stories that geologists do detective work and tell us, and every time now you look at a rock, you must say, I wonder where it came from. I wonder how old it is. I wonder what all it has seen in its lifetime. Right? Fun, right? So geology is fun as well. We'll come back and talk more about what is next is the discoverers of the greenhouse. So we are slowly getting into modern climate change. When we say climate change, people say natural climate change, which happened before, like the ice ages and the melting of the ice and so on. Now when we say climate change, we are mostly talking about human beings increasing the greenhouse gases, trapping more of the thermal energy, warming the temperatures, and causing all these other changes that we will talk about. Okay, see you in the next podcast then, children.